Hi. I need help with physics.
You need anything?
I need help with kinematics. It's really hard.
Did someone say kinematics?
Yeah. I need help with it.
I have a solution for you. Follow me. Here, son. A mission is like a vector. It requires both direction and magnitude. Otherwise, it's just energy. Sit down. You see this pencil, right? What's the velocity at the top? It was 0. You see it again? What was the acceleration though? It was not pointing. Although the velocity was 0, there was still an acceleration. That is kinematics. That is the question you have implored.
Alright, so here's our 4 basic equations for kinematics. Before I tell you about them, I just want you guys to know that these equations are blind and they only see in one dimension. So it'll be either along the x-axis or y-axis depending. You may have to split into components. Alright, so the first equation is velocity final is equal to velocity initial plus acceleration times time. The second equation is distance is equal to velocity initial times time plus 1/2 times acceleration times time squared. Third one is velocity final squared is equal to velocity initial squared plus 2 times acceleration times distance. And the final one is distance or average distance is equal to average velocity, which is times time, and average velocity is equal to the final velocity plus the initial velocity over 2 and then multiplied by time. And remember that you determine which equation to use based on the givens, and most of the time you're going to need at least 3 of the variables to solve. That's it. You can end it now. Please.
These are the quantities and units in kinematics. First off, it's distance. It's the length of space between two things, and its SI unit is meters or m. Next is displacement, which is the distance from the origin. Displacement is a vector, so its direction affects its outcome. So the SI unit for is meters or m. Speed is the rate of change of distance, and it is not a vector, which differs it from velocity. And its unit is meters per second. Next is velocity. It's speed with a given direction. So velocity is a vector which will affect its outcome based on its direction that it is going. So its unit is meters divided by seconds. Next is acceleration. It's the rate of change of velocity. Acceleration is also a vector, so depending on where the direction is, it affects how much the acceleration is and in which direction it is. And its unit is meters per second or meters over second squared.
Alright, so here's the graphs for kinematics. The first one shows just a straight line that is horizontal and parallel with the x-axis. And what this means is that the object is not moving or it's stationary. And here you could see a train that's stationary, not moving. Next, we have a position versus time graph where the line is increasing but it's straight. And this shows an object moving at a constant speed. Alright, and lastly, we have a position versus time graph with a curve or a parabola. This describes an object that is accelerating. Wow. Alright, so if you guys remember, speed or velocity is equal to distance over time. What that means is speed is also equal to meters over second. You can equate that to position over time as the slope is rise over run or y over x. What that means is that with position graphs, position versus times graphs or distance versus times graphs, the slope of the line is equal to the velocity. So here the slope of the line is 0 as it doesn't rise. The object is stationary, velocity is 0. Over here there's a straight line increasing. The slope of the line is a number it means that there's a constant velocity as it doesn't change. And then over here, you have the slope constantly changing. You could find that by drawing a line tangent to the slope at that given point, like this, or like this. And then what this means is that since the line keeps increasing, it means speed is also increasing or accelerating. One.
What's good, Low Gang? We're here with another vlog. This time we're going to do a 100-foot drop test here in the beautiful city of LA. The weather's beautiful, and we have a brand new iPhone 5s. We don't have 2 brand new iPhone 5s. We don't have 3. We have 1 brand new iPhone 5 with the outer box. Comment below, do you think it'll survive? I'm going to put a poll up in at the top left icon over there. Comment below. I'd like to see what you guys think. I personally don't think it'll survive. Remember, share, subscribe, like, comment. Make sure to dab on the haters. Let's get. What's going on, Scarce here? Today we are right now at the drop zone. We are about to do the unprecedented. This is the first news outlet covering the story. We are about to drop the brand new iPhone 5s from a 100-foot drop. It's absolutely astonishing, but we are going to do it. We're going to do it in 3, 2. Actually, leave in the comments what you guys think below. Thank you. It's about it. Into it. 3, 2, 1.
What is going on, guys? Jake Paul here. You are the Jake Paulers, and I'm about to take this shot. This is a projectile. Comment down below if you think I'm gonna make it. By the way, I'm taking this shot because I'm almost too bad at basketball. Here we go.
Okay, man, do it.
Can we just like edit it?
Go.
What's up, guys? FBS Russia here. We are going to do the impossible, the unprecedented. We are going to send a basketball up with only a vertical velocity. We are going to do something never done before. Let's get right into it.
Now shoot!
What? No!